Okay, so if you're actually checking all this out, this is the last one. The cotan. All right. So you know how to graph good old cotan graph. It's just a series of these curves. The domain of the cotan graph would be all real numbers, except we have to exclude the asymptotes. So if I've just got a series of these curves, which are just going on for infinity, just over and over and over, you look at it and say, well, this is definitely not one-to-one, so its inverse won't be a function. So in order to restrict it, we easy enough just said, well, we'll just take one curve by itself. So we're going to ignore everything else and just take that one curve. The domain of this one curve, the numbers we can plug into cotan to find the answer, is 0 to pi, but 0 and pi don't are excluded because those are asymptotes. The range, the set of answers, all real numbers, it's going up and down. So when we do the inverse, we just swap this. This is our restricted domain, by the way. That becomes our range, which is the set of answers. So our answers for cotan graphs are always going to be between 0 and pi. The range, which becomes the domain of the inverse, is all real numbers. That means I can plug anything in the universe into a cotan problem. Inverse cotan, I mean. Inverse cotan of any real number should have an answer. But we'll get to the calculator problems later. Right now, we're only doing unit circle. So here's our range, our set of answers, That's the critical thing, our set of answers. Well, if you notice, our set of answers are from 0 to pi, which once again is first and second quadrant, just like cosine and secant. So remember, first quadrant is just the reference angles. That's easy. So when it's positive, we just do the reference. Second quadrant is just the regular second quadrant angles. Okay. So cotan has the same restrictions as cosine and secant, first and second quadrant. Okay. So then we look at it and say, all right, when I see a question like this, I read it. It's an inverse problem. So I say, what angle has a cotan of 1? Oh, unit circle, that's pi over 4. What angle has a cotan of -1? Well, when cotan gets a 1 or a -1, we know the reference angle is pi over 4, but oh no, it's negative, and cotan inverse of a negative is in the second quadrant, which is just 3 pi over 4. When does cotan get the √3? Oh, well, that's at the pi over 6s. When does cotan get negative √3? Well, √3 we know is a pi over 6, but it's negative, so that puts it in the second quadrant, so 5 pi over 6. Inverse cotan of 0, what angle has a cotan of 0? When does cotan equal to 0? When does cotan equal to 0? Well, that's good old pi over 2. Okay, what angle has a cotan of 0? What angle has a cotan of 0? That's good old pi over 2. Okay, so these are all just unit circle. So once again, the critical thing is the restriction on cotan is first and second quadrant. Okay, and like I said, I'm going to make a whole video just going over all the restrictions all together. And you don't have to memorize this, but you do need to know, what logically, what the answers look like, what logically works.